Hi everyone, welcome to another Wolfram Language Design Review. This is a kind of forward-looking design review about error handling. So let's maybe Leonid, you can summarize what we're talking about here.
Yeah, all right, thank you. So basically, it has been realized by many people inside and outside the company for a long time that there it will be very beneficial for the error handling to be based on exceptions, not just in addition to other ways of error handling, which are more applicable for smaller projects. Uh, the largest projects, they benefit from exception propagation because the intermediate functions then don't have to care about handling errors, only the ones which are supposed to catch this or that error. And so far, Wolfram language hasn't had a standardized model for that. And so uh, this is the error tools project or packlet as well is an attempt to define and implement such model and to empower developers with the error handling tools that are especially useful for larger projects, but that can actually be used on projects on any scale. Uh, and here we have some important points listed about these details of why error tools or this approach uh, might be a good thing, and not in the least part because uh, almost every large project inside and outside the company defines its own framework, essentially based on exceptions. But those frameworks are custom, non-standardized, and so basically everyone reinvents the wheel every time. So this is probably one reason why which we want to prevent. The other thing is, if we have the standardized model, then everyone who starts using that, they might have essentially for free all kind of updates and new features that we add to the framework. For example, things like propagating additional error information or fine-grained debugging, or maybe error logging or stack trace reporting. All these things will just immediately become available.
Or handling errors in parallel processes, for example,
Yes, I didn't think about that, but surely that could also be a part of it.
because that's a
Um,
mess right now.
yeah. So basically, this is this attempt to both standardize and implement things. And on the other hand, we try to be minimalistic in the sense that we tried not to invent too many new things. We tried maybe to improve existing things and only introduce new things when absolutely necessary. Um, and so here is the list of basically how does this compare to what we already have. So first thing to notice is that throw and catch by themselves, they are good primitives, but they're a bit too low level for us for this purpose. And in
Yeah,
fact,
I get
we
it. Yeah.
Mhm.
Okay.
Okay.
Confirm and close seems much closer.
Oh yes, confirm and close is much closer, but confirm and close it implements a somewhat different model, which is a little bit smaller scale. So I mean, in principle, you could use confirm and close with the tag, like the third argument, which
Mhm.
is somewhat equivalent to what we propose.
Okay, but
But
we can't have multiple mechanisms running around, so we need to make sure we can integrate these things.
yeah, but I think I will probably not be mistaken in saying that the vast majority of people who use confirm and close, they use the lexical version of that, which is essentially local exceptions, which are caught immediately at the enclosing function.
Yes.
So we have in this notebook down below, we have examples of how these two approaches coexist.
Okay.
So they coexist quite nicely,
All right.
at least in
Keep
our
going.
opinion. Okay.
Let's get into
Okay. So
some.
here is a list of features. Essentially, it's exception-based propagation, and we have also lightweight error type system with type inheritance and selective error catching. So basically, you can be selective on what you catch and what you allow to sort of go through. And also we emphasize safety, so you never catch exceptions that you don't throw. And we try to make things declarative and stateless. And again, interop with the confirming clause. And the status you can read here
To flag
basically.
again the value of making sure we interoperate with parallel stuff, with remote batch submit stuff, all these kinds of things.
Let me just.
Actually, how does right now, I mean, throw and catch, I assume, don't work at all with parallel stuff, right?
No, I mean they don't cross the boundary between master and subkernels, but I mean that's something that is entirely doable. For example, aborts
Yeah,
actually propagate back. So I mean once we have a framework, then I can lift that to the parallel framework so that you could
right.
actually generate errors that would on the subkernels that would be caught on the master kernel, and if that is desirable.
Right. I mean, my guess is that all this, I mean, confirm and close, and I think all this stuff is built on throw and catch, right? So presumably it's just if throw and catch work, then everything can work.
Mm-hmm.
Yeah, probably. Also because this new approach is also built on throw and catch. So it means that
Right,
yeah,
Okay,
you're
right.
so
probably
fine.
right.
So that becomes the thing. Can we throw out of a parallel process, out of a sub process, and land in the main process? In other words, what happens? It's rather undefined. What happens at the top level of a process? I mean, we just get at the level of the REPL. It just says, uncaught throw.
Yeah, that's what happens currently. But now in parallel tools, I actually have a catch all around the remote evaluation, so it never breaks the loop, but it doesn't do anything with that caught exception. And in the future, it's quite thinkable that it could actually propagate it forward and reissue the exception on the master kernel.
Right. Okay. All right.
Okay, so the status of this is that, well, obviously we think at least a part of this is ready for design review today and can be completed pretty in a short order.
All right. Okay. Let's see some actual design.
Okay, so we decided to start with the basic examples, which will illustrate to you all the design.
Okay.
So essentially, this is the most basic example we can think of. When we want to handle error in this way, first we create an error type, which is a symbol. So
Okay.
we basically say that this symbol is now an error type. And so once we do that, we register it. And then when we want to raise an error in this new framework, here is the code. And if under certain conditions, it raises the error with this
But
tag.
ABC is not something which has a value. ABC is just some
Yeah,
thing without a value used as a tag.
yeah, exactly.
Well,
ABC
So
tag.
actually, I
it's
was going
more
to
like,
ask,
yeah.
does it have like a down? Because I noticed it turned black. Does it have some like up
Yeah,
value or
it has.
something or
It
what?
does. For example, well, it's
Oh,
going a little bit. mm, I mean, I'm going in front of myself, but we have some shortcuts which allow you to raise exceptions easier, and this is one of them. But there are no own values, so this is a symbol
Yeah, I
which.
get it. I get it. I mean,
Uh,
it seems more sensible to call it raise. I mean, sorry, register, whatever it is. Anyway, keep going. Keep going. Keep
okay.
going.
Okay. Well, sure. So here is a function. And the other ingredient to catch the error, so J and H are intermediate functions, is handle. And you can see yet another ingredient, which is failure pattern. I will explain in detail what all of these are, but just bear with me for a second. So basically, if we just do normal execution pass, this, even without handling, will just produce essentially f of 3 just becomes 3. But in this case, it's 7, so we should raise an exception. So if I just do 7, I'm getting, it looks like normal failure, but it is not. And in fact, was Christopher's idea originally to wrap this in some sort of, uh, you know, display form that would show it somewhat differently. And it's just this display obviously should be changed, or we are not even
Yeah,
sure
yeah,
it's
yeah,
a good
yeah.
idea. But this is the original one, how it should look like if you do not wrap it. So this is just to show
What do
this.
you mean don't wrap? What's the wrapping?
right.
Wrap.
So there's the point is I think the point is that this, I mean, this is a little scary. I mean, basically, this was an uncaught throw.
Mhm.
So it threw to the quote unquote top level, like when you use throw and there's no catch. And
Yep.
so if you don't do anything, it looks, you can see there that hold of throw of failure is like actually what was thrown, but it's been reformatted in some way to make it clearer that it was thrown to the top level and not merely a returned failure.
Well, I mean, the main loop could do something with that uncaught throw.
Right. And that's one of the questions that we wanted to discuss with you as open design questions. But even apart from that, I mean, that could be another solution to this. But the solution that we sort of also considering is that if we decide against it for whatever reason, then there is this option that throw has a third argument, which is what we're using here, which basically, whenever some exception is uncaught, it wraps it into whatever function is the third argument of throw. And this is what was used here. Whereas,
Actually,
yeah,
maybe a quick question. I mean, maybe it would make sense to have another cell type. I mean, like we have message. I think messages are their own cell
Okay.
type, right? And we have
Yeah.
output cells. I mean, maybe there could be some sort of exception cell that has maybe different brackets and maybe a different whatever it's called, the thing on the left, the prompt, to make it more obvious that this is like not output. Because I think that part of the issue, I mean, part of the reason why if you show a failure object like that, you need to have some weird formatting around it, is
yeah,
because people, we discussed this before, but like people get really confused if you throw something to the top level, because then they'll try and wrap some function around it and then be confused where that function went. Because
yeah, exactly. Like, look,
yeah.
input form, and there is nothing because it
Yeah, I
it
think
eats up.
Christopher's idea is a very good one. I think this
Okay.
because nobody types percent and expects that to refer to a message. See what I'm saying?
Right.
Yeah. So there is this possibility. Then, Steven, what you also mentioned, let me just write it down here. That
Although actually, sorry.
Yeah,
Or,
sure.
okay, go ahead.
Make the main loop catch that.
Right.
So one question though, right, is, well, I mean, the main loop, I mean, when you have an uncaught throw, I mean, the main loop does catch
Do
it.
something. Yeah.
I mean, yeah. But I guess one question would be, so what's the value? Okay, so messages. Okay, so there's two things that if we had, some special exception cell type, right, there'd be sort of two differences. One is that, when an exception cell is thrown, it stops everything, unlike, messages, which don't stop everything. The other difference would just be the formatting, that messages are, basically just red strings, where this is a failure object. So the question is, what is the value of it looking like a failure object if it's a purely, or if it's a mostly visual thing? Or is the point that you can refer to it with percent in order to like inspect its contents and so on?
So you mean it should
Does that make
probably then
sense?
look different?
No. Look, there's
Well,
two possibilities here. One is it's purely visual thing, in which case a new cell type that just says uncaught exception error is the right thing. Or alternatively, the main loop can turn the uncaught throw into some actual piece of symbolic stuff that could be queried, and which is assigned to an output line.
Well, no, kind of. I mean, the question is just like, for example, like even just this mock-up that you have here, Leonid, like when a failure, when that uncaught exception failure gets returned to the top level. So the question is, like, should that display as a failure object, or should it display as some other thing? Because failure objects are partly meant to be visually consumed, but they're also meant to be like programmatically consumed. So the question is, I mean, like, for example, if you could refer to this thing with percent, then I think it would make a lot of sense for it to be a failure object, because then you can compute with it.
And this comes very much intact with what Steven suggested, because if main loop catches it, then basically it boils down to whether percent can be whether we can refer to that as a percent.
Okay, I think we're going down a rabbit hole here. Let's see the big picture, which we haven't completely seen yet.
Sure. So essentially, when you add this statement handle, well, actually, not the statement, the function.
Okay, so it has a headdress thing,
Yeah,
and then its payload is it's like an evaluation. It's like a controlled evaluation.
Yeah, and it's not even a head race, it's just a function with an operator form.
I see.
So,
Actually, how does that
oh, sorry.
work with how does that
Just
work with attributes? Doesn't it need to have a hold for
yeah,
its
it does. Basically, this evaluates to a function
hmm,
with a hold first attribute. At least that's how, this is the only way to implement it without the help of the kernel.
for the evaluator?
Yeah, the evaluator, because it's essentially if we want the sub value like behavior, the
Yeah,
operator
we
form.
get it. We get it. Right.
Mhm.
Yes, I understand. But
Okay,
okay, but let's just get the bigger picture. Okay, so we've
sure.
got this thing, handle,
So
where, go ahead.
yeah, so essentially, even this small example shows all the main ingredients. So you have array types that you can define. You have arrays to raise them, and you have handle with certain patterns to catch them. But then there is the next example builds on this simple one to make it a little bit more realistic.
Doesn't catch, I mean, catch has, I don't understand why this is different from the patterns that catch has.
Yeah, the difference is that essentially here, the failure object that we propagate is self-contained. So it contains all the error information, including the tag. So we do not, basically, if you just use catch, then you sort of split your error into two pieces. You need to know in your catch, I mean, underlying thing is indeed the catch. But in this case, what happens is that what handle does, it always catches all exceptions. But then if it's an exception that is not supposed to be caught, then
Yeah.
it re-raises that. And so that allows us to use only a single
Okay.
service error tag underneath.
How does it relate to the event handler mechanisms in the front end?
Um,
Because those also have things for propagating events up and down chains and so on. You should make sure you know how those work.
yeah, I know how those work. At least I've did fair amount of front-end programming on the not on front-end team level, obviously, but I don't think there is a direct connection
Okay.
here.
All right. Okay.
So let me show you a bit more realistic example, which shows you a little bit
Leonid,
more details.
Leonid,
Yeah.
I mean, would this stuff interact weirdly um, with preemptive evaluation or weird modes that can happen? Like this, all you're showing is always the main evaluator.
Mm-hmm.
So do you see that some of this might not work in?
So insofar as we use block internally, that might get in the way because I know that preemptive evaluations don't like blocked variables. So we don't use it much, but we were thinking, for example, to enable handle, outermost handle, and this is one of design questions I actually wanted to discuss, whether we should force outermost handle to always catch all inner exceptions. But if we don't do that, then I think we don't really use block or things like that. So I don't see
Okay, but
maybe,
hold on.
yeah,
Let's just pin this point. These unusual forms of evaluation, like preemptive evaluation, like dynamics,
yeah.
like local evaluate, like these kinds of things.
Okay, let
And
me just write this down.
okay, this is getting recorded, so and I think we have somebody.
Okay,
So
preemptive.
Claudia, I hope, is taking some notes here.
Yeah, no problem.
Okay,
You don't
I
have to.
don't
You don't have to
think.
take these notes.
Okay, fine. But I don't think I don't see immediately where this can bite us.
Okay, I just want to point out all these things that are separate processes, all this kind of thing. We have to figure out what transmission of errors is or isn't with
Yeah.
respect to those things. But let's keep going because I still
Okay.
want to get the bigger picture.
Okay, so
But I mean, what I'm seeing so far is a sort of controlled vocabulary of errors. That is, you are defining, you're registering error types.
Yeah.
So that you have a sort of a controlled collection of possible errors.
Yeah.
And you are raising those. I hate the term raise for this purpose, but anyway, never mind that.
Well, it's more or less standard for
I'm well
programming
aware.
languages.
I'm well aware. Well aware along with other silly things that people, yeah, anyway, it's incomprehensible to anybody who doesn't. Anyway, never mind. Doesn't matter. We keep going.
Okay. So yeah, I mean, you're right. This is the but I think you'll see hopefully that this is somewhat more than just
Okay,
the
keep going. So we got two error types.
Okay, so
defined.
here what we are defining are error types which are child error types for this ABC. So now we define slightly more complex version of this function, which also has this catch-all definition. So if nothing matches it, it throws error of a different type. And now also you can see that raise not just throws the error itself, but it adds certain information that it propagates with the error. Which
That's
we
not
have
a controlled vocabulary. That's just random things put in an association or not.
Yeah, this is random thing put in an association.
Okay.
And now when we can now handle this, obviously, like here we're handling this error. Okay, this is normal execution path. So this one would just execute even without this, or just all right. But in here, we're trying to handle both of these errors with the failure pattern, which only refers to only one of them, which is this wrong value. And you see that obviously first error was caught, but the second error was not, because
Yeah.
it's a different type of error.
I get it. Why
But
those aren't
now,
on two separate lines, I have no idea. But anyway, go ahead. Yes.
right, but
Yeah.
now we can have more inside handle. We can have more clauses, and you can see you can not just use patterns, you can also use rules. So these rules basically tell you that you can do something with the resulting error after you catch it. So in this case, we essentially, one of the errors we just return, the other one we also echo, just to show that you can pretty much do what you want with it.
Yep.
Now you can see also something that might look a bit weird, that the tag in the failure here is actually not a single like symbol. It's now a list of symbols. And this is a pretty essential feature for this framework, because what we do, we expand all the like the tag plus all the parent tags, so that essentially we try to make things as stateless as possible. So at the time when we raise, you first expand all these tags. And so the common sort of composite tag that we're sending this failure with is a list of these tags. And that allows us to do selective catching based on hierarchies. So this is about this tag expansion. And also notice that inside handle, you can use also patterns, not just failure pattern. You can use, for example, underscore. It's just not recommended because it's too generic. Now, this expansion allows us to do the type inheritance, because you can catch both of these errors using just the ABC tag, error type, which is a parent of both those specific error types.
Yep.
And now the question is, why do we want to use failure pattern? Well, because these simple things will always work, but they are too generic. And if you try to match against just ABC, then obviously because of the tag expansion, this will not work, because the real failure that is being emitted has this expansion here. The failure pattern actually takes care of that. So that's why
Well,
it
I
is
don't understand why. I mean, in handle,
yeah.
Can there be? Why not just have handle insert a failure pattern around its argument by default?
Well, because we want to distinguish between a failure and the tag. So if I do here,
But we're not going to use the raw tags.
We might. For example, it's not yet supported, but we could do something like this. That here it will be tag type of, and then alternatives, something like this. And then somehow we may be able to pass this type along. I'm not sure.
Okay.
But
all right. Okay. Fine.
if we
keep going. I just want to see the whole design.
Okay. So so I showed you type inheritance, and then this is just a slightly larger illustration. It's the same sort of function, but now we dress it with a public facing function which has the error translation. So essentially this is this big handle which transforms the failure that we catch with the public-facing failure. And this is partly to show that what we really want to do as this boilerplate is to automate it away. And the error translation layer, which we don't yet have, but which we are kind of working on, will be automating these things away completely. But this is how it looks so far. And then there is this helper function that emits a message. And then once we execute this, we can see that there are no signs of these internal messages, and we're just essentially.
I'm sorry, what internal messages?
Sorry, internal failures, because all these failures which we catch, they are being replaced by public-facing
What caused
failures.
it to emit a message?
The code to emit a message?
No, why did it emit a message? Why did the func of 10 emit a message?
Because we program it this way.
But where does it say? Where does it actually say? Oh, I see. Okay, there's where it said it.
Yeah.
Okay, but so that emit message on failure, you're proposing that be a function.
This will be a part of the error translation layer. For normally, what will happen? I mean,
what does an error translation layer look like? So I mean, that's part of handle. Handle is going to do error translation. Is that correct?
What we would rather do is to not overload handle too much, but maybe you're right. So error translation layer, I'm somewhat unprepared to show it today, but basically you will do something like this. Register error translation.
I don't understand why some things are create error type and the other is register no. I mean, well, whatever. Go on.
I can somewhat explain why. Because there is no direct relation between types and public functions which want to catch message errors. So in a sense, one and the same error type can be caught by several different public functions, and they will all work differently. So in that sense, that the registry that we want to register a translation.
No, I got it. I got that. That's different. I don't think the name create error type is even close to correct.
Possibly, yeah. That's.
I mean, if this is register, why isn't that register as well?
Yeah, maybe it's register type, and this is. I mean, you see, naming of functions is the first thing on our list.
Okay. Keep going.
Okay, so here it will look like this. It will be func, maybe goes to, and this will be.
No, but func is your definition. I'm very confused.
It's the public function
that you are trying to define.
Yeah.
That has a real contentful definition.
Yeah. Okay. And then it will be something like, for example, ABC wrong value.
So this is like the error value of the function func.
Yeah. So maybe
it should be called that.
So what is your suggestion to call this?
I'm not suggesting it very seriously, but just write down error function of func equals. Right, func colon equals blah blah blah. I mean, that's
and then there will be this.
No, yeah, that kind of thing. But I don't know if that's at all correct.
Yeah,
you're saying a per function basis, just like we can have format value of func is such and such.
Yeah.
You're saying
it will be a little bit more complicated than that because, for example, if there isn't a rule defined for a function, but there is a generic rule defined for the type, then we might use
what type? The type
error
of the error.
Yeah.
Okay, but there are two things here. There's the function, which has its behavior, and then there's an error type.
Yes.
That has its behavior.
Yes.
But I don't quite understand. I mean, it seems to me that many functions will want to do the same thing. And I might have a whole family of functions that want the same error handling.
That's right. So we will need a way to indicate multiple functions here as well. Which I mean, I would say probably this error function and error translation is somewhat separate topic, which we will need to discuss the design of.
But what is this doing? What is it fundamentally doing? It's fundamentally saying that if this function, if you are returning from inside that function, it is a form of handling that happens for that function that causes it. I don't understand why this is different from handle. I just don't.
Can I explain?
Sure.
So the imagine you have a large framework like Tabular or the databases stuff that we did. We have a lot of different messages that are basically for
Whoops. Hello. You
our
dropped
own
out.
internal debugging and contain very comprehensible.
Go on. You dropped out for a second there.
So when you're calling the internal function directly, you see a bunch of stuff that you mostly want to simplify and explain in clearer terms for end users, but it's super useful for us developers. And these things happens over and over again. And as a matter of fact, basically, Rob.
You keep on dropping out, Carlo. Hello.
Did the same exact same
Carlo,
pattern
you keep on dropping out. We can't.
Sorry.
Okay.
Okay, I'm getting closer to the Wi-Fi. So what I was saying is that we have this pattern where we have internal failures that
Yeah, I got it. We got it. Where there's internal failures that need to be bank switched out for some externally visible failures.
Yeah.
Okay.
Right. So this this will look something like this, and essentially, it's mostly will be function and then the type, the error type, and this also would allow us to do. But I think, and we've discussed it to some extent, that it would be also good for the error types to have their default behaviors if the error type is being called.
Let's keep this a little simpler, okay? As I understand it, you have this controlled collection of error types with a certain amount of hierarchy.
Yeah.
Okay?
Yeah.
From within any piece of code, you can say the very horrible name raise, which, let's say, because the reason I hate the term raise is because it takes immediate action, which is not what you think from the word raise. See what I'm saying? It takes immediate action. It exits where you are, correct?
Yeah.
Which is completely not what you would expect. Raise just seems like I'm going to raise a flag, and that's what it came from originally, because the way that compilers worked and so on was very different from what we're doing here. We have immediate action. Get out of here, right? Is what this really means.
Yeah.
But okay, so we have this thing, exception, whatever we're going to call it. That causes us to propagate upwards, and then we can have at any level, if I understand correctly, we can have a handle which sees that exception go past it, so to speak. And that handle can decide what to do when it sees a certain exception go past it. Is that correct?
Yeah, that's correct. It can, in particular, it can either catch it or it can make it pass by, allow it to pass by.
Okay, so how does that relate to the confirm and close framework, which also has that kind of mechanism?
In confirm and close, it's somewhat different. You wrap and close around the code where you use confirm inside, but confirm and close is not allowed to pass things through. So if you do close of, I don't know, f of g of confirm $failed, then you will catch all these confirms, and unless you use the tags, the third argument of confirm, enclose will basically catch it all. It's one difference. The other is that here, all those f and g, they can enclose and confirm. They, at least for the lexical part, they have to be within the same lexical.
Yeah, I get it. Unless you use tags.
Unless you use tags. Here, obviously, because these are exceptions, you don't have this. And the other thing is,
wait, stop for a second, okay? If you use tags and if you control the vocabulary of the tags, why is this different?
Well, it may be not so different conceptually, but it surely is very different on a technical level because
well, there's a few things. I mean, the first is stuff like tag inheritance.
Yeah.
which is, because right now, I mean, at least right now in close, I mean, the way it deals with tags is basically the same as how throw and catch does, which is, the tag has to literally match.
Right.
So I mean that's one difference. I mean, also some of the stuff around, well, yeah.
But
Yeah, also there are things like, for example, tags. I didn't mention that before because this is below in some examples. Tags have properties, and
yeah, I get it. Okay, so let's just
Yeah,
okay,
I think one
confirm.
thing about the error translation layer, I mean, if you didn't have that, then all your code, if you write one of your public functions that users will actually use from a package, it will all be essentially a big handle with elaborate patterns matching and generating of
Yeah, I
messages.
get it.
And so with this, I mean, you could have this error function for all the functions from your package in a single place. So
What is the thing that we do that is the version of confirm that doesn't test anything, that just always fails and always goes to its enclosing close?
I think in the end we don't have one of those. You can do
I see.
confirm is sort of false.
Okay, fine, because that's what this exception function is doing. It says confirm is doing something contingent on its content, right? Which is solving a different problem than the problem of generating an exception. In other words, the thing that causes you to generate an exception isn't, confirm generates something. It's not one of these exceptions of the type we're talking about here yet.
yeah.
You know what I'm saying?
I
But I
mean,
mean, confirm
yes.
quiet is a useful piece of functionality that is independent, is orthogonal to the question of whether it generates an exception or just a throw or whatever it is.
Yeah, I think that, I mean, the various variants of confirm, they all have their built-in tests, right?
Yes,
And so
which is different.
which is limiting its use. And here we turn it around. We have the tests, and if something goes wrong, then you raise an
I
error.
understand, but we need to unify these things. Okay, we're not just making another code base for the sake of making another code base.
Right, but Steven, I mean, confirm and close generally, if we can presume that the vast majority of confirm and
Can I
close,
make a general principle here?
sure.
Look, we figure out what we want. We do not always look behind us saying, how are we going to make this bridge? I don't think that's a very good analogy, but you get what I'm saying. Let's stop worrying about how we're going to implement it. Okay, let's figure out what we actually want. One thing that's useful about confirming close is that it has things like confirm quiet. That's a useful thing, which is a different thing from what we would need to do with exception, which exception just says kaboom, like throw, just do it. See what I'm saying?
Well,
Yeah,
I think the
but
point is just that the confirm functions both check if something went wrong and then also
Yeah, I know. They do.
basically use throw to propagate.
Yes, right. So let's figure out how we unify the throw to propagate thing, but we're not well,
right.
that's
I mean,
not what we want. That we just write exception instead of raise. Raise is horrible.
fine,
Do
sure.
you understand why I'm not going for that? It's like flags and semaphores and all this nonsense. It's a different thing. It's not
Yeah,
what
but
we
it should
want.
be a
It's a
verb,
take
Steve.
action. Okay, fair enough. Well, so
Except.
yeah, except we
Except
already have
no,
that.
it's a pattern.
We
Right.
know very well. I mean, it needs to be something that doesn't sound like it's a static symbolic thing, like raise exception. Yeah, throw exception would be it. That's a fine. Let's use that as a current term. Throw exception is a fine action type thing.
All right.
Okay.
Right,
Or
but
even throw failure.
okay, let me just write this down so that we don't like did it remain
exception.
Yeah,
and
although
throw
throw failure sounds a little bit like, why is it different from throw of failure? And especially if we had a different
true.
exception cell type and stuff like that, then it would
right.
be
So
very
throw
different.
exception
But we'll
sounds like a
see.
pretty good name. Okay, so let's say
Except
throw
that's
exception.
long, but yeah.
Okay, but Steven, I wanted to address your main point about the relationship of this with the confirm and close things.
Why?
I think
Why are we talking about that right now? Let's not talk about that. We're putting that on the side. Let's figure out what we want this design to be.
Okay.
Okay. So we got throw exception, and then understanding that. So then let's just write down throw exception and handle exception. Yes, they're long. We'll worry about that later. Okay. It's actually handle exceptions plural, is it not?
Well, it's always one exception. It's just that it
No, but
can be of different type.
Yes, but it's handle exceptions plural, I think. Throw exception. It's defining how to handle exceptions that come past this particular place, right?
Yep.
And okay, so let's just understand, what does throw exception have in it? What is it? It has, we have registered, let's look, can we write down another function here? Register exception type, or just register exception. No, register exception type is perhaps the right thing. Let's just write register exception type for the time being.
Yeah.
Okay, so now we type something. I don't know why it's a symbol. Why is it a symbol? Because you want to do some weird down value thing?
No. Not just because of that. That's a secondary. The primary thing is that we want to ensure uniqueness so that there are no name collisions. And symbols are good for that because they have natural uniqueness coming from contexts.
And basically they'd be scoped to a package or something like that.
Yeah. So typical workflow is that people just define these symbols in their packages. Let me show you something very quickly, because I was going to show it later, but since we have this discussion path. So if I just call array types, I'm sorry, again, the names, this is not even supposed probably to be a public function, but if I now load tabular, it creates a bunch of these array types, and they all, like you can see, all of these.
Are those, what context are those actually? Oh yeah.
Yeah.
Okay.
All of these are created in the tabular backtick context. So this makes them guaranteed to be unique. And this is one of the key safety things that we wanted to ensure. And this is why we recommend against string tags, for example.
Okay, it's an interesting idea. Okay, so
and
let's
these are
assume
the internal errors, right? Like users would not typically see these.
Yeah,
It's translated into a tabular failure. Yeah.
Yeah, and of course, down values and the ability to attach some properties or stateful properties is a nice bonus, but not necessarily a requirement.
Okay,
but
all right, okay, I get it. So
okay, so going back to your
register exception type, which could also be something where you say sort of exception value or something of a symbol equals whatever.
How would I type this? Like this?
No, not in there. Outside, separate line, exception value of ABC error.
Yeah, well, it's just ABC.
Okay, colon equals blah, blah, blah.
But that would suggest that you could have several of these. You could have own values, down values, exception values, and that's certainly not the case.
So
these are tags. They cannot have any other values.
Well, but wouldn't it be nice if then, okay, so if you say register exception type, then it should presumably lock these symbols so you can't give them values.
Yes, so what we currently do is that we protect those tags, but we so far allow some simple down value at assignments, for example, but we may change that. So ABC is protected.
Okay, I get it. So, okay, so you're registering that exception type. You're giving its hierarchy, correct?
Yeah.
And okay, all right. Now with the handle exceptions, what are you doing there? You're saying which exceptions to handle in this handler, and you might be giving rules to say what to do when it passes that handler, what to do with that exception. Correct?
Yeah, so it's either expr comma rules or patterns, or it's the at least the way we currently have it, or it's just rules and then this is the operator.
Yeah, I know. Okay, fine. Put it in. Put it in of expa. But in the operative form, just say yeah. Right.
Yeah.
Okay, fine. Okay, and we know there's some slight issues with attributes there. All right. Okay. So keep going. So what are the other features of this? So
Okay, one thing I wanted to show you. Okay, these are design questions we can probably skip for now and focus on later. Most of these things you've seen. One thing which is sort of might not be obvious is that you can handle an exception and then do something with it as a failure, and then you can re-raise it. So basically, you can just raise of the, so basically handle is now
what the
just,
heck are you doing here? Are these separate cells up here?
no, this is a single cell. So basically,
they're as if they have semicolons between them. Why did you put them in a single cell? I don't understand. I mean, these are just separate. You're just saying at the top level, you're saying
Yeah.
raise of handled. I don't understand that. You've got to
No,
throw
but
exception
that
at
would
the top level.
typically be inside a function, right? With
Yeah.
semicolons in between.
Yeah,
Yes.
So can I, again, this happened a large number of times in Tabular, and I think maybe this example kind of obscures where this is useful. But in general, what you have is internal functions raise instead of returning a failure, so that the exception propagates all the way up.
Yes.
But sometimes you use external facing functions inside. And so you want to switch back to the mode where whenever they return an exception, that exception has to keep bubbling up. So it's not returned, but rather it's thrown again, rethrown. So it's like you want to unhandle things that were previously handled.
yes.
Because
So
you're using an
I
external
don't
function.
understand. What is this code? What is this piece of code? Are you proposing? I just don't understand what this is. So the handled
this
thing,
is
go
not
ahead.
proposing anything new. It just
Okay, what
uses
is handled? What is the value of handled after you execute that first line?
it's a failure. So let me
Oh,
just
for God's
show
sake.
you.
This is what you get for putting all these things together. We have cells for a reason, so you can see the output before you see the next one.
Okay, so sorry, handled.
No, you don't even need to do that. You don't need to do that. Just evaluate that first cell.
Yeah.
Evaluate the first cell. It says
Sure.
handled equals something. Okay, there we go. Okay, it's a failure object. Now you say print the tag version of that. Okay, fine. Now we say throw that exception again. Okay.
Yeah. So what this shows is that there can be more complex workflows where you handle something in between, like in your inner functions, do something with it, and then you re-raise
I don't
it.
understand how that first thing can possibly make sense, because if the thing is executing normally, you've got this crazy thing that says handled equals, but handled could be set to 17 because it's just returning normally. You understand what I'm saying? If there's no raise in there, handled was normally just a value of that function returning.
Yeah. Yeah, see, what typically happens is that you don't do it like that with just raise. Like the function unhandle we have in Tabular is something that checks whether the thing you get out is a failure or whether it doesn't match.
Okay, that's very much like confirming close.
Yeah, it's very much like that.
Well, actually, one question is there a way of well, I guess there was some of this for the inside the argument for handle, but like it seems like the thing you want to do is you don't want to just see that a failure object came out and assume that it came from raise and that you can then re-raise it, right? Like
Yeah.
Yep.
Yeah, I would expect typically to be the re-raise to happen inside the handle on the right-hand side of the rules. Right?
Yeah, I have we have examples like this. Just give me a second so that everything is intact.
But like a typical situation where that happens is like think about join across and column wise combine implemented one with the other. But internally you still want sometimes to rethrow the errors in
a
different.
better example is aggregate rows. So the third argument, aggregate rows, gets grouped, but those may be rules that are given to transform columns. So we first call transform columns to get the columns you're aggregating over. And within aggregate rows, that's an internal call. So we re-raise if that's called from aggregate rows. Does that make sense?
Okay, but yes, but
Yeah.
this is exactly what confirm is supposed to deal with, is what to pass through and what not.
Except Stephen, confirm only work if we talk about lexical confirms. They only work.
I know, but this is not lexical, right? But we've
Yeah.
already got a mechanism. We don't have to invent a new mechanism. We can use that mechanism. I don't know exactly how we make the bridge, right? But we're not inventing a whole new mechanism for this. We've already got a way of propagating, deciding whether there was an error. If there was an error, doing something with it. If there wasn't an error, just returning the values, which is what we want here, right?
Right, but the thing about this is that the biggest meat of both confirm and close and this framework is an error propagation, and the conditions and all these nice things, they're more about syntax that we may want to introduce some extra, like a richer syntax for example, throw exception or something, where we could insert some conditions or have a versions of that would check for conditions and do similar thing. But the mechanisms of error propagation are quite different in confirm and close and in this
Why?
framework.
They're both using throw.
Because in confirm, if we assume that
Assume that
confirm,
we don't have the tag in confirm. Yes,
Yeah.
it's different. It has a default tag that works lexically.
Yeah.
In this case, we are never working lexically. We're always expecting to have a tag capable of infinite propagation.
Yeah.
Right?
Right.
But that doesn't mean design-wise that we shouldn't be trying to fit these things together.
But that tag doesn't carry information, right?
The tag can be whatever you want.
There's no way to have these kind of failure types and
What are you
distinguish
talking about?
between
We could decide to do that. It's a convention what that tag is.
You mean the tag in confirm?
Yes.
But the whole reason why we wanted to go away from these three arguments was the tag, is that we wanted to make exception a self-contained object.
Guys, listen. Confirm does certain things. You are reinventing a bunch of those things in some stupid parallel universe here. Don't do it.
I don't think you're correct, Sivan. Sorry, but I don't think this is correct.
We've got things that we know we need to do with exceptions. Throw exception is a different piece of functionality than anything with confirm.
Yeah.
But this translation, this thing where you either pass it or you don't, that's much more like what confirm does.
But confirm doesn't decide this. Confirm decides it on the level when it raises thing. And here handle is an analog of enclose, not confirm.
No. Okay, let's keep going. I'm telling you, these things need to be unified, and they can be. But keep going here.
I mean, I think the main unification, if anything, would probably be to make confirm use sort of the same tags, like have tag inheritance and stuff, like is here.
Yeah.
Yes. Yes. I mean, confirms tags are Wild West right now. They don't need to be.
Right, but in addition to changing that would probably imply a unification of handle and enclose. That's something that probably would make sense.
All right, so we have to look at that. Let's look at that.
Okay, so I have a few examples of the interaction with confirm and close, but they are of a somewhat different nature. So basically, what I'm showing here is that if you get the result as a result of confirm and close pair, then obviously you can raise confirm is because we also realize the need of unification, Stephen.
Yeah. Okay. Listen, we're running out of time here. Can we not look at this particular thing?
Sure.
Let's see.
Let me show you one last thing, and then we're done. Okay.
Yeah. Okay.
For today, I wanted to show a very practically useful thing, which is a debug mode. So basically, I'm just creating these types again for completeness. I'm recreating these definitions.
I don't know why you don't use separate cells. Okay, go on.
So this is this public function that we basically uses this f, and f uses g, and g uses func. And then when we execute this is normal execution. Here we have an exception, so we only had that far, and then there was an exception that was caught. But here we turn on debug mode. And you see in the debug mode, the outer failure that we're producing contains now the inner failure that provides the developer with the useful details about what was going wrong. And important thing here is that debug mode is set on a tag basis, on per type. So it's selective. You can switch it on for your particular error types of your application. And extension of that is if you want to show stack traces. So this is based on stack, and this is the same thing, but now, again, don't pay attention to the UI, it's ugly. But the main point is, in databases project, we had enormous benefits from implementing this stack traces because it allows you to basically.
I get it. Okay, so let me just understand what actually happened here.
Sure.
So you're saying for that exception tag, what is the difference between what's happening? And normally in a handle, you do not propagate the inner failures.
Yeah.
Right? You just
Exactly.
use the failure, whatever failure thing was being generated by that handle, but you never do the inheritance of the inner failures.
Yeah.
So what this is doing is it's saying, is it really with respect to the, okay, so it's saying if this error type, exception type is generated, then tell all the handles that they should propagate the inner failures as well. Is that correct?
It's slightly different. What actually happens is that at the point when we raise exception, we provide it with this new information, not at the point when we catch it. But other than that, you're correct.
Okay.
And what's really important about this and what makes it useful.
Wait a second. Sure. So you're just making a bigger bundle. Why are you not, for efficiency, you're not always generating all that information in the case of arrays?
For efficiency, and also because, mostly for efficiency.
Okay, so this is essentially in throw exception. You're saying, I mean, in general, there should be some option to throw exception that says whether to send all this extra information or not.
Yes.
And you're saying this is what determines the value of that option for a particular exception that you might be throwing in throw exception. It's just an outer way of doing that.
Yes, I mean, you don't want to have that in your code. You want to switch debug on and off independently. And I mean, exceptions are not errors all the time. So debugging is not always required. It's only when the exceptions don't do.
I agree, although I'd like to point out that our general experience with assignment type stuff like assume versus assuming and so on, our general experience has been wrappers work better than than kind of assignment type things. Just saying.
Well, for example, I find on and off quite useful.
That's good. They've been there since
that's the kind of yes.
Yeah, it's similar to that.
I have felt that those are kind of the old world before we were much more sort of oriented towards sort of symbolic nesting. But
yes, but sometimes I mean, to find an error, you don't need the most sophisticated tools. You need something that
I know, but I can see the value of. I mean, this is like, by the way, it just reminds me of we should probably have a wrapper form of seed random. Just a small point.
Well, there's block random and then seed random, which is.
I know, but then you give seed random, but it could just say with seeding.
No, but we have block random. I use all the time block random of block, random seeding goes to such. That's the option.
Yes, but it would be nice to have an operator form that just says with seeding, and then you wrap it around some.
Right. I think the nice thing about block random of seed random is then it makes it totally clear, like what if you're doing multiple random operations that you're not reseeding every time.
Well, this is not for this discussion, but it occurs to me that I would have used that a million times because I've got code where I've written the code and then I have to put seed random semicolon blah blah blah, which I hate. It'd be much more convenient to just have some operator form that says with seeding at blah. Anyway, small point. Okay, but let's look. So okay, so did we capture most of the design here, or is there some giant iceberg?
No, I think we captured most of the design except that error translation layer, which we just sketched over. But
okay, so error translation, just so I understand what it is it has to do with you just handled something.
Yeah.
And the handling can have side effects. That's what the right-hand sides of the rules for the handler are, correct?
Yeah.
Okay, what is the translation? What happens then?
This is up to us to determine, but in the 95 probably % of cases, what people really do, they translate failure and they emit a single message or less commonly more than one message. So essentially, if someone needs more sophisticated things, they can write their custom handle.
But I don't understand. I don't understand. What we've got right now, I see. So you're saying instead of explicitly writing exception handlers or exception, what do we have? Exception, what was the name that we had there?
Just a
Row
second.
exception
Row
and then
exception.
It's handle exceptions.
Handle exceptions. Okay, so instead of explicitly having handle exceptions, is that right? Where handle exceptions says for this error type, for this exception type, do this, blah blah blah.
Yeah.
This is an alternative to handle exceptions. Is that correct?
Yes. It will basically, the only thing which is kind of important is that we probably want first exceptions to be caught and then translation to be pure.
I'm trying to understand, what are you trying to avoid? If you say handle exceptions and then you've got a lot of detail about ABC goes to echo whatever, right? You're trying to make something which does not require that.
Yeah, I would like to avoid. Yeah, we would like to avoid this boilerplate.
Right. So what you want to do is you want to define centrally for a particular exception type. Whenever this exception type is handled, do this. Without, is that correct?
Slightly more complex. We want to define it for specific top-level function first. And if there is no such rule, then yes, it will be using a central rule for a specific type.
Yeah, so it's in a way the other way around. We define what to do when an exception is not handled. And instead of just throwing it to top level with an error, we make something sensible for the user.
Okay, so you're saying if handle exceptions does not have an entry for tag blah blah blah, that exception will not be handled at that level, and at some point it will propagate to top level, and then the question is, what does it do when it propagates to top level? Is that right?
Yeah, but that's a separate thing. That's what we discussed at the start, what to do with those exceptions. I think error translation layer is about something different. It's just to reduce the boilerplate for developers who write this, who would otherwise write this huge.
What is that doing? That's basically just saying those are the right-hand sides of, you're saying whenever I catch ABC bad args, here's what I want the default right-hand side to be. Is that correct?
Yeah, because you see,
that's what
it's much more declarative this way.
Yes, I get it. I get it. Okay, so what you're defining is, you're saying when you say handle exceptions of ABC, you want there to be a default action associated with ABC that happens when it is handled, correct?
With ABC and also with top-level functions, if you want to define that for them as well.
What do you mean top-level functions? I'm sorry, what do you mean?
Like func here is the implemented top-level function, right? For example, it can be some of the functions that we implement for the users.
Okay, hold on. So you're saying two things. You're saying if handle exceptions would have a tag ABC in it, then you want to define what the default behavior that happens whenever tag ABC is caught.
Yeah.
That's thing number one.
Yeah.
Correct?
Yeah.
Thing number two, you're saying whenever tag ABC is thrown as an exception in user-defined function func, then you want to supply this right-hand side. So in other words, there are, I think, about 4 sources of right-hand sides. Right-hand sides being what happens when the exception is handled by okay. There's what happens when the exception is handled by a handle exceptions. What happens when the thing gets all the way to top level without having ever been handled, right? And so
Yeah,
I think
correct.
there are sources, so we can talk about this as the action associated with that exception. Okay, so let's write down where that action can be defined. The action can be defined in the throw exception, in throw exception, right? If you write this down, please.
Yeah, okay.
Okay, the places where the action can be defined.
But
okay, so
throw
yes,
exception doesn't define really any action. It just
it
throws.
could perfectly well define an action. You could say for this particular exception, I want, because it knows the tag, right? So throw exception has the tag, and so it can give an action to take when the tag associated with this particular exception is handled.
Right, Steven, but that is recorded in the tag properties, not in the throw exceptions.
But it could be in the throw exception. You could make an exception to the exception.
Okay,
to
fine.
say, in this instance of this exception, I want this to happen, right?
Okay, sure.
Okay, so no, in throw exception.
I would argue, I
singular.
mean, then you should use a different tag.
Probably so.
Yeah,
Question,
but okay.
It's throw exception singular, and there's a question mark after this. It's throw exception singular. Get rid of the S. Get rid of the S.
Oh yeah, right.
Okay, next place. In handle exceptions, in a particular handle exceptions, you can give tag arrow action, right?
Yeah.
That's what you're doing, right? Okay, next case, right? Next case is for a given tag, right? You can say anytime that there are 2 things. First, when this tag is handled by handle exceptions, right? When this tag is handled. And there are actually 3 cases of that, right? It's generically whenever it hits handle exceptions, when it hits the top level, and when it hits handle exceptions in a particular function.
Right. Except well, let me just first write it down.
I need to go very soon.
In a particular. But the way we envision that would be that essentially the implementer of a function like func.
I know. I understand. It says that
they'll do
right.
something like error translate,
or
whatever we call it.
I know. It's an error value, so to speak.
Yeah, error value, exactly.
Right. But I think that it will be nice to combine that with something which is if this function doesn't match these patterns, then go to this error case.
Yeah,
which we don't have here.
Well,
you only have it in the way of saying func triple blank blah blah blah, which I don't think is the right way to do it.
One thing we were thinking of doing is that basically there will be this ABC, which is a parent tag for everything in this project. And if it's missing, and if it's caught, then ABC itself is like here, basically the second case, right, that you mentioned. ABC itself will have some prescription what to do in that case. So even if we are not specifying it here, but then the tag itself could have.
But you're not writing down places where the action can be defined. That's not those things you wrote down as sub cases. The third one hits the top level and hits exception handler. That's a case where you are. See, that's case 2. Now there's a separate case 3. There's a case 3. Where is the action specified? Right. The action can be specified centrally for a tag.
Yeah.
Well, let's clean this up. You'll clean this up later.
Okay, so places in throw exception is 1.
Yes.
So you say there is
the second one is in handle exceptions. We just
okay.
Oh, for goodness sake. You just wrote it there. You don't need to write it again.
Okay.
Right?
It's just yeah, I'm trying to
Okay.
follow your ideas.
Yeah, okay.
So
Then hits the top level is a different level, right? Thank you. Yes. Okay. So that's the action can be specified centrally for the tag, right?
Right.
Centrally for the tag.
Correct.
That's just one of the items. That's the third item. After it can be specified in throw exception, it can be specified in handle exceptions, then it can be specified for the tag, right? Do you understand what I'm saying? Either you specify the action in a specific handle exceptions, or you
Yeah.
specify the action centrally for the tag.
Oh,
When
you mean
yes,
basically this.
that. No, next
Then
level
this.
up. That.
Okay.
Okay, take those two gray items and put them underneath the centrally for the tag. Those two gray items
Okay.
underneath the centrally for the tag. Right? Okay, so once you say what happens centrally for the tag, it's either, it can either be whenever this is hits a handle exceptions, or, right? Did you understand what I'm saying?
Yeah, I think, but can you complete the sentence so that I'm
Yes. Okay. So the first in the action specified centrally for the tag, case one, it will always happen whenever it hits a handle exceptions. Case two, this is what to do if it hits the top level. No, it's not. It's a lower. It's cases underneath can be specified centrally for the tag.
well,
This is
we
why I
are
can't
running out
stand
of
not to.
this.
Yeah.
Okay.
No. It's the three cases under when it's specified centrally for the tag.
Okay, hits the top level is one. This I
Yes,
understand.
another one is hits any handle exceptions. That's the third one of those cases in the gray thing. Hits any handle exceptions. Right? And that other case you just wrote is hits the handle exceptions for a particular function.
Yeah, this is the second case.
Yes. Okay.
Right.
So now now in the larger the dot, the unfilled dot underneath there is the other thing, which is where the action can be defined, right? And you're saying the action can be defined for a particular function. That's what your error function of func is doing. Do you understand? The fourth,
Yeah.
just fill it in there for a particular function.
All right.
Right? That's for a particular function, like func. You're saying what to do for a particular function. Say what to do with each tag.
Exactly.
Type in say what to do with each tag. No, not
Here,
underneath.
okay.
It's all the same thing. Say what to do with each tag.
Right.
Okay. Do you agree with these four cases?
Okay, so in throw exception, possibly yes, but as Christopher
We don't
said,
know.
maybe
We're not sure about that one.
yeah. In handle exception,
That's
yeah.
the whole point. That's what you already specified. You already
Right.
defined that one.
The only thing that I would say here is that probably the particular function should come first because
What do you mean by first? There's no list. This is just a list of possibilities.
I think what Leonid is saying is that the third and fourth, you have kind of to define which takes precedence and probably.
We're not saying what takes precedence. I'm making a list of what the possibilities are. I'm not saying what precedence is.
All right, but Steven, in practice, we will hit a very particular instance of handle exceptions, which will be either, for which if it's within a particular function, there will be rules for that, and if it's those rules are omitted, then we use a more general rule for the tag because.
Okay, I'm not defining. I am not telling you the precedence order. I was trying to get you to write down the cases.
Okay.
Okay.
Then yeah, I agree.
Okay, thank you. All right. Okay. So I mean, what we do for handle exceptions, it's very clear what the syntax is. Could you please put an N in the handle exceptions thing? It's driving me crazy. You got handle exceptions. At the top, second item. There, that one.
Okay.
Yes.
Sure.
Thank you.
Yeah.
Okay.
I mean, sorry.
Okay. We understand the syntax for number 2 there. The action can be specified centrally for the tag. That's your register, type in parens at the end of that first line. Action can be specified centrally for the tag. That's in register exception or something. That's what it means to specify it centrally for the tag, correct?
Yeah, register. What was the name we ended up with?
It doesn't matter, but it could be in
Exception
register
type.
exception. No,
Yeah.
just say register exception.
Yeah.
Okay? Okay. Now the fourth case is the thing we're talking about, error function of a function, right? The fourth case is like error function of a function. I don't really like that, but that's okay.
Yeah. Right.
Okay. All right. I have to go. I'm sorry. We should continue this. Can we try to continue this within a week so that we haven't lost all the information about this?
I'm afraid we can't because I'm leaving on PTO. Unless it's going to be without me.
Well, when do we next get to do this then?
I'm back in the start of September.
I hope we have good notes from this meeting, because I'd like to start from where we left off.
I think everything is recorded, so we'll review it before Leonid leaves.
Okay, and can we please make sure that we get the things that we did manage to conclude here, that we get them, captured. I understand roughly what this is. It seems quite sensible to me, but it has quite a bit of grinding to do before it's a clean design, in my view.
That's fine.
Christopher, do you have any last comments on this?
No, nothing in particular.
Okay. We really should figure out how the confirm and close stuff dovetails with this, because I think it can.
Yeah.
All right. This is great. Okay. See you in a month or so, I guess.
Thanks, Stu.
All right. Okay. Bye.